I'm starting out with the default atmosphere. So if you go to atmospheres and load atmosphere, you can find the default for daytime, spectral sunshine, and that's the first one on the list. It is different than the physical default. I'm going to start out by adding in a cloud layer, and I'm going to choose the thick cumulus layer. Or actually, we'll use the dense cumulus layer. I'm going to go over to the Cloud tab in the Atmosphere Editor, and we're going to edit the material. And we're going to be using altitude offset for cloud modulation to extend down the cone, the tornado. And what we're going to do is add in, once we edit the function, just by clicking on the driver the function button, adding a noise node, and we're going to change that over to math pattern and tooth triangular. And we're going to need to scale that up. And one thing I want to note is that the scale is different for the modulation settings. It is a separate material size from the detail layer and the density production. So what we can also do is limit the cloud to a zone. Right now, looks like we've got the altitude offset too high. If you take a look in the Cloud tab, there's a altitude variation setting, and this directly controls the maximum influence of the cloud modulation. So with anything that the altitude variation is at 100%, typically you don't really see much of anything. So what we want to do is basically adjust the height of the cone with the altitude variation. And I'm going to need to extend the value of this, maybe scale it up as well. Change the size until it starts to show up. We can just start to see it. I'm going to remove the vector seed, and then we'll change the position of the clouds. After we set up this noise node, we can add a filter to the link, numeric filter. Go ahead and change that. We can use map. And our output should be between 1 and -1 because we're using a noise node. That usually doesn't go beyond that. So our input range can be -1 to 1, and then we can set our upper value and lower values. Looks like we need to flip it. So we'll set the lower range to maybe 2. Let's see if we can do 1 and -1, maybe -2. You can just start seeing the cone kind of show up from the noise. And if we need to, we can also offset the noise by changing the origin. Maybe 0.2. And we can change the height of the cloud. And we want the altitude to be basically 0. And if we go back into the atmosphere editor and edit the cloud again, I'm going to go back to the modulation and just modify the settings a little. And actually, I'm going to remove the origin offset because of the way it's connected to the altitude. And now that I have the cloud lower to the ground, I don't really need to offset it. And now we can fine-tune it kind of with the altitude variation. To adjust how high we want that influence to go. And then if we want to change the size of the cloud zone with the cloud selected, we can go to the Move Cloud Layer, Move Limiting Zone, click on that, and then we can size, use the size gizmo to change the scale of it. Because basically we want to separate the cone from the rest of the tornado, or the rest of the clouds, as part of the cell. Because it's going to be a lot easier to animate this by adjusting the altitude variations. We can also go into altitude offset, height modulation. It's probably the best way to animate this one. We'll take a look at that in a minute. First I want to get the rest of the clouds kind of set up, and then we can also adjust the lighting. So now we're going to go ahead and add another cloud layer. We can use the dense cumulus layer again, or another one, just making sure that we kind of offset them so they don't look completely identical. And what I want to do is just bring down the altitude so that it starts to somewhat engulf the cone layer. And we'll go ahead and rename the layer below it so that we know which one is the tornado. And we can go ahead and just kind of adjust the altitude and just take a look at the main camera view and just kind of see exactly where the layer is showing up. Now, if you want, you can also limit the cloud to the zone, or to a zone, and set up maybe a fall off of, let's say, 20. We can go ahead and activate the zone size. Maybe just fill up the screen a little bit with it, and it should basically blend into the haze. Now also, if we want, we can fine-tune the altitude using gizmos. And then if we go back to the atmosphere editor, the tornado, we can just kind of adjust our altitude variations and kind of set everything up. And here's a quick render of the two cloud layers. As you can see, it's a good idea not to trust entirely the smaller render window. For some of the finer details and lighting, it's a good idea to just go ahead and do a render, take a look at it, because a lot of times the quality setting for not only the camera preview, but also smaller renders of the scene, larger renders always give the best quality. But you can get a better idea of what the cloud layer is really going to look like by just doing a full render, or at least something close to it. Going to the atmosphere editor, that dense cumulus layer, the layer, when rendered, is very plain in color, there's not really any holes in it and not a lot of places for light to shine through. So we can adjust a couple of things. There's just the overall density, which will keep sort of the same consistency of light throughout it, but allow more light to come through it, lighten it up a bit overall. We can also adjust the opacity level, which is basically the point in which light is blocked and no longer can penetrate through the cloud layer. And then the ambient lighting starts. So with the opacity, you're adjusting kind of the edge fall off of the lighting or the internal fall off of the cloud based on the density within the fractal and also the detail layer, which is multiplied into it. So we could also bring down the opacity to allow light to shine through a bit more. And bring up the density a little more. And now we can see a lot more light shining through the cloud, reaching the bottom a bit more, and it certainly doesn't look like the main camera view. At least the small preview that we have here. To kind of compensate for that, one thing you can do is pull out the render window on the right so that you can render a little larger and see things better. The only problem is this is a single core render, and sometimes it's just faster to do a regular render that's smaller, because then you can utilize all cores in your CPU. Otherwise you're just waiting for one core to render something out. I'm just going to change the preview quality to fast and make this update a little quicker. Another thing is if we go to the Sky Fog and Haze tab, we currently have no interaction between the shadows of the clouds. So one thing we could do is turn on projected shadows on clouds, and it's going to project the shadow downward and onto the cone layer and darken that up. We'll also start to see some of the internal shadows of that layer on the layer above it. And the other method is to use a volumetric sunlight, which will block the clouds, or the light from the clouds, using shadows and also utilizing the atmosphere. And as you can see, it starts to darken the haze and the sky from the cloud layer. And the intensity of that is based on the shadow density and the actual density of the cloud. It does take a bit longer to render the volumetric light, so the projected shadows will go a lot faster. And another thing you can use together with that is the God rays. So that way you can affect the atmosphere and still get shadows on the clouds from not only cloud layers but also objects. So if we had a landscape in the scene, that would also cast a shadow on the clouds. We would see that show up. So you can use these two together or use just the volumetric sunlight by itself. Sometimes you can also use volumetric sunlight plus God rays to get an extra bit of darkening in the atmosphere if you're noticing that some of the atmospheric effects are not appearing as they would with the other settings on. So right now what I'm going to do is go back to the zone for that larger layer, the dense cumulus layer that's on top, and just increase the size of it to fall off a bit more into the haze. The cloud layers render much faster whenever you limit them to a zone. So it does make it a lot easier to work with it. Now, to adjust the cone so that it reaches more of the ground, one thing we could do is to adjust the sea level. The sea level basically is the start of the atmosphere, and then the start of the cloud layers as well, and then they are linked together. If we raise the sea level, it will raise all the cloud layers. The only problem is if we lower the sea level, the objects become unpredictable. Basically what will happen is the previews of where the clouds are at isn't actually going to reflect where the clouds really are at, and it makes it really difficult to work with. So I don't really like moving the sea level too much. Instead, what I'd rather do is move the ground to meet the objects. It does make it a lot easier. So what we can do is just raise the ground up to meet the cone. And then if we had a terrain in here, we would just do the same thing, or just remove the ground layer and just have a terrain that's a little higher. If you need to compensate the atmosphere, one thing you can do is adjust the decay altitude in order to show some of those lower level colors that we're basically cutting off by raising the ground level above the sea level. So one thing you can do is take the decay and make it higher than the sky altitude, and that does balance it out. And it also makes the sky a little more green. And I also want to go back to the cloud layer, or the cloud tab, and adjust the tornado. And what we could do is, if we want to have light kind of shine through it a bit more, we could adjust the opacity level, and then we'll be able to see it a little better, keeping in mind that there's still going to be the shadows from the layer above it, which will limit the amount of light we're really able to see on it. So if we need to, we can adjust the shadow density on that, and also on the tornado itself if you want ambient lighting. Also adjusting density. We could lighten it up a lot by reducing the density amount, or we could go the other route and create a very dense cloud for the cone, and then it'll really sharpen it up and define it within the scene. The detail layer plays a large role in the look of the cloud. We can adjust how much we see the detail layer and multiply into the density layer. So we have our density production, and then there is a detail slider that uses the cloud layer detail and multiplies those values into the density production, or subtracts, mixes with them. It really depends on the strength of the other sliders and the overall output of the density production in order to create the cloud layer that's more detailed, or a little sharper, and part of the internal function, and that scale is also independent of the density scale and completely independent of the cloud modulation scale. So I could even change this density scale and detail scale of the material and bring it up to 1, and the cone should stay in exactly the same place, but what we're adjusting is the rest of the cloud layer. Bring that back to 0.05 for now. Now, since tornadoes are usually part of very large cells and cumulonimbus clouds, we want to add another, or we need to add another layer that's going to reach much higher into the atmosphere and darken everything up even more. So I'm going to add another cloud layer. We'll just use the thick cumulus layer. Change its height. And I'm going to limit it to a cloud zone. We can extend our zone and then move the cloud layer down. remembering that this is going to basically cast shadows on everything below it. So then we can kind of fine-tune where we want the front or the highest point of our cloud to show. I think we'll just go ahead and leave it right there for now. So this is mostly shadow influence with this layer because we really don't see any other parts of it unless we were to take the dense cumulus layer and move that. Now I'm going to go ahead and just throw a material on the ground. I'm going to use one of the landscape materials, and we'll just use the grass variations, just to get a little color on the ground. Now, because of the way the cloud modulation works, we can't just move the cloud layer to move the tornado if we wanted to animate it or set up keyframes. What we have to do is modify the cloud modulation in the origin. So I'm going to go ahead and just scale that down for a minute. So basically, to move the tornado, we need to move the origin. You can see as I start to move it along the x-axis, the cone from the toothed triangular noise that is generating the cone starts to move. Another thing we could do is assign this origin to an external dependency of an object that we can move the tornado with, other than the object and the cloud layer itself, which is, if we were to animate it, it's going to move the detail layer and the density production layer and animate that internal function. It's not going to animate the origin of our modulation, so it'll stay completely still while everything else kind of moves through it. That does help with the animation, but we still need to be able to move the cone, so I'm going to add an object, just add a sphere. We'll go ahead and scale it up. We're going to click to make sure that it doesn't render. We also want to make sure it's not going to affect ecosystems when populated. We can ignore indirect lighting on it, but it's not rendered anyway, so it shouldn't have an impact on indirect lighting. But what we want to use is the position to control the origin. So we'll go back into the tornado layer, edit, go to the modulation settings, and then we can add an input node, external dependency, and choose the sphere position. And we want to make sure we set the position to the default display unit, which mine is 1 meter. And go to File, Options, Units and Coordinates. One view unit is 1 meter, and that's so we have the correct unit coming out of here to control the origin here. And there might be an offset because the layer itself is offset from itself. It may not be at 0. So we may need to subtract the position of the object itself first. Now, the reason this actually isn't working is because the sphere's position is on the Z way too high. Because if you remember, we moved the ground plane up. So if we go to the sphere and set the Z position to 0, we can now move the tornado. And it looks like the scale of the material might be affecting the overall influence of the origin, multiplying it too high. Make sure it's on default display unit. I do believe I might have changed it. So maybe we can bring it down to centimeters and get something a little better out of it. I'm just trying to make it less sensitive. Or maybe it needs to be more sensitive. Try kilometers. So it looks like if we set it to kilometers, we should be alright. Okay, so our output from the sphere's position, if we move it, now we should see the cone angle moving. Keeping in mind that it is within the zone and the cloud zone. So as we start to move that offset or the outside of the zone, it will be clipped. So you do have to sort of keyframe the zone with it. But assigning the origin to this object will allow you to animate the tornado moving. And then you can also animate the cloud layer and the zone, keyframe all of those to create more motion. If you want to have the tornado sort of coming down from the clouds, then you can keyframe the altitude variation. And it looks like in this case the best thing to do would be to start with a high altitude variation and work your way down until it touches the ground. So maybe starting around 60 and coming down to 50, and that should bring it down from the cloud layer. You could also adjust the height or the altitude of the cloud layer to make it come down that way. A lot of different ways you can kind of shape it out. Also a good idea to rename the sphere or anything you're really using as an object for that.